Here's an expression. See if you can find the extrema on the domain where x is greater than or equal to 5, and it goes all the way up to infinity. Now looking at the graph, we can see that x at its lowest point is equal to 5. And when x is equal to 5, this expression is at its lowest point. G of x is equal to negative 100 right here. And so this point here, this is the minimum point or minimum value. As x gets larger, g of x also gets larger. So here we have x is equal to 1 million. Now g of x isn't even equal to 1,000, but that doesn't matter. What matters is that g of x is continuing to increase. And so there is no maximum point. There's no maximum point. G of x as x increases is not heading to a specific value. Previously, we looked at extreme points. Economists are particularly interested in a kind of extreme point called an interior extreme point. And so these occur not at the beginning or the end of the domain. So if I were to draw a diagram here, and I'll just use a linear example. Suppose I've got a linear line like that, and the domain is A to B, then, and maybe we could just call this f of x, and we could put a y up here, x over there, x-axis. The interior of f of x is A to B with round brackets. So any point not equal to A or B and in the domain. So the domain here is x has to be greater than A and less than B. Now I'm going to show you that if C, some point C, is an interior extreme point for the function f, it is a necessary condition that the derivative f prime c be equal to 0. This is essentially saying that the slope is equal to 0. So we can say that whenever f prime of x is equal to 0, x could be an extreme value. Could be. It's not guaranteed to be an extreme value. It could be. And we're going to look in more detail about what I mean when I say it could be an extreme value. We're going to look at situations where it is. We're going to look at situations where it is not. Now, any point x in the interior of the domain where f prime x is equal to 0, we call these critical points. So if f prime x1 is equal to 0, then x1 is a critical point. Or if f prime 2 is equal to 0, then 2, or x equals 2, is a critical point. Oh, I didn't quite spell that correctly. In univariate calculus, whenever f prime is equal to 0, the tangent line is what shape? It's going to be horizontal. So here's one of the graphs we looked at earlier, and I told you that D was an extreme value or an extreme point, and it was a minimum. Notice that if I draw a tangent line here, and if I get it just right, it's going to be a horizontal line. F prime D is equal to 0. And it has to be, because if D is a critical point, for the function f prime D must be equal to 0. Here's a function we looked at earlier. We've got a question. The question is asking us, is there an interior extreme point? Looking at the graph, is there any point on this graph where the function is horizontal? Looking at the graph, the answer is no. There is no horizontal point. So no. There is no interior extreme point. Nowhere is g prime of x equal to 0. Therefore, there can be no interior critical point. There can be no interior critical point because at no point on this diagram is g of x horizontal. Here's the expression we looked at before. Maybe I'll go over it one more time. I already told you that D is an extreme point. Only here at D do we have the function horizontal, right? Where we have the derivative of g prime of x is equal to 0. We've got another question. It says, find all critical points and interior extreme values. So we know that a critical point is any position where f prime of x is equal to 0. And if f prime of x is equal to 0, then f of x could be an interior extreme value. And so we've actually got the lines drawn for us here. You can see that there's a horizontal line at D, a horizontal line at C. The domain is, well, x has to be greater than A and less than B. Here's our domain. And C is a max. The function doesn't get any higher than it does at point C. And D is a min. The function doesn't get any lower than it does right here at D. And when I say right here D, I'm just sort of pointing at the y-axis intercept. Here's another one. So find all critical points and interior extreme values. So we have a critical point at XO. That's why we've got that horizontal line there. We've got another critical point at X1. And we have a third critical point at X2. Are any of these points interior extreme values? We have no interior extreme values. The extreme values occur at B and A, where A is a minimum and B is a maximum, but neither are on the interior. And we've got a domain here, A is less than X less than B, or maybe we can include the A and B points. So these are extrema. These are extreme points, but not interior.